Good morning, friends. In previous lecture, we have discussed magnetohydrodynamics source or plant. Summary of magnetohydrodynamics plant is concerned with the flow of conducting fluid in presence of magnetic and electric field. MHD power generation is a new system of electric power generation which is said to be high efficiency and low pollution. In advanced country, MHD generators are widely used, but in developing countries like India, it is still under construction. The construction work is in progress at Trichy in Tamil Nadu under a joint effort of BARC. BARC means long form Baba Atomic Research Center, BHEL Associate Center Corporation (ACC), and Russian Technologies. The fluid may be gas at elevated temperature or liquid metal like sodium or potassium. An MHD generator is a device for converting heat energy of fuel directly into electrical energy without conventional electric generator. Now, today we will discuss fuel cell, a new emerging technology. Fuel cell, an electrochemical device that continuously converts the chemical energy of fuel into electricity and heat without combustion. Fuel cell is a device that uses hydrogen or hydrogen-rich fuel and oxygen to create electricity by an electrochemical process. If pure hydrogen is used as a fuel, fuel cell emits only heat and water as a byproduct. Fuel cell versus electrical cell both have positive electrode and negative electrode and an electrolyte between them. Fuel cell require continuous supply of fuel and oxidant. It generates DC power and heat. Both produces DC power. Electrical cell or battery store the electrical charge and it discharge after supply of power and needs recharging. Main component of fuel cell: a fuel electrode, an oxidant, air electrode, cathode, and electrolyte. Electrolyte is a solution of H2SO4 for acidic fuel cell and KOH for alkali fuel cell. Application of fuel cell: space application, ocean ship, automobile, portable power plant, military use for power generation. Application: fuel cell generator, fuel cell bus, fuel cell car, power generation, like that. Why we want to use fuel cell? Environmental concern of using fossil fuel, poisonous emission, oil crisis, global warming. Fuel cell is a controlled chemical and electrical energy conversion device which continuously converts chemical energy to electrical energy. In a hydrogen-oxygen fuel cell, electrochemical reaction involves the process of ionization in which atom or molecule loses or gain one or more electrons. Losing one electron gives the atom overall positive charge and gaining an electron gives negative charge. Water can be ionized into hydroxyl ion and hydrogen ion when two dissimilar metal electrodes like sodium, zinc, cadmium is placed in solution containing ion. Voltage is developed between positively charged electrodes. In a fuel cell, the reactant are continuously fed to the cell and electrically it is extracted. Therefore, the fuel cell is like storage battery but with regular supply of fuel and oxygen. Here we can show figure of fuel cell, anode and cathode, and here in electrolyte reaction done H2 plus 2H plus 2 electron 1 of O2 plus 2H plus 2 electron equal byproduct H2O. Overall H2 plus 1 of O2 byproduct H2O. Fuel cell component: Electrolyte membranes transport ion, block electron gases. Electrolyte catalyzed reaction transport ion electron gases. May be composite catalyst plus conductor plus pore former. Membranes of electrode assembly MEA. Fuel cell. Some of the fuel cells are hydrogen, oxygen, H2O2, hydrazine, carbon, coal, methane. Hydrogen oxygen fuel cells are efficient and highly developed. In the hydroxyl, catalyst is embedded in nickel electrode. The electrolyte is typically 30% KOH because of its high electrical conductivity and it is less corrosion than acid. Cell reaction are anode reaction 2H2, 4H plus 4 electron. Cathode reaction 2H2 plus O2, 2H2O, vapor plus energy. H2 is fed to one electrode and it is absorbed. It gives off free electron and also react with hydroxyl ion of the electrolyte to form water. The free electron travel toward the oxygen electrode through the external circuit. The two electrons at external circuit combine with one molecule of water to form two OH negative ions. These OH negative ions migrate toward H2 electrode are consumed there. The electrolyte remains invariant. The cell operates at or slightly above atmospheric pressure and at temperature of about 90 degrees Celsius. This type of cell are called low temperature cell. In high pressure, cell pressure is up to about 45 atmosphere and temperature is up to 300 degrees Celsius. A single hydrogen oxygen fuel can produce an EMF of 1.23 volt at atmospheric pressure and 25 degree by connecting number of cells. It is possible to create useful potential of 100 to 1000 volt and power levels of 1 kilowatt to nearly 100 megawatt. The overall efficiency of the cell is the ratio of power generated and the heating value of the hydrogen consumed. Comparison between different types of fuel cell. Here we can show types of electrode. Comparison between different type of fuel cell. Expect PMFC, AFC, PAFC, MCFC and SOFC. According to different aspect, here comparison is shown in this table. Types of fuel cell. PMFC, proton exchange membrane fuel cell or polymer electrode membrane. AFC, alkaline fuel cell. PAFC, phosphoric acid fuel cell. MCFC, molten carbonate fuel cell. SOFC, solid oxide fuel cell. Fuel cell choice. Temperature, sheet, operational parameter and fuel choice. Ambient temperature, high temperature. Ambient temperature, rapid startup, H2CH3OH as a fuel catalyst is Jiri poison application, portable power, mini on-off cycle, small size. High temperature, fuel flexible, very high efficiency, long startup application, stationary power, auxiliary power in portable system. How fuel cell work? A fuel cell is a device that uses hydrogen and oxygen to create electricity by electrochemical process. A single fuel cell consists of electrolyte sandwiched between two thin electrodes, a porous anode and cathode. Types of fuel cell: polymer electrolyte membranes, phosphoric acid, direct methanol, alkaline, molten carbonate, solid oxide, regenerative, reversible. Polymer electrolyte membranes, also called SPEFC, solid polymer electrolyte fuel cell, use a proton exchange membranes as an electrolyte. Low temperature fuel cell, 85 to 105 degrees Celsius. Nafion membranes developed by DuPont consist of a polytetrafluoroethylene base structure, polymer electrolyte membranes. Here figure shows polymer electrolyte membranes (PEM), alkaline fuel cell electrolyte KOH in H2O, liquid in matrix or liquid recirculated, mobile basis OH minus, half cell reaction anode H2 plus 2OH, 2H2O plus 2 electron minus, cathode 1 half O2 plus H2O plus 2 electron, byproduct 2OH, 2OH. Catalyst, anode cathode. Unlike other fuel cell, rapid cathode kinetics, slower anode features, high power output due to rapid electrocatalyst rest, inexpensive material, highly sensitive to CO2, used by NASA for manned mission, alkaline, phosphoric acid fuel cell, electrolyte H3PO4 plus H2O approximately 20%, liquid in SiC matrix, mobile series H plus, half cell reaction, anode H2, 2 hydrogen atom plus 2 electron, cathode 1 half O2 plus 2H plus 2E H2O, catalyst anode plus cathode PT, Hurricane carbon, PT coarsen with time, phosphorate absorbed to surface. Like most fuel cell, slow cathode kinetic, faster anode. Feature low power output due to slow cathode kinetics, expensive catalyst, and very high cost per power output. Catalyst relatively insensitive to CO due to high temperature. Commercialized in 1990, then abandoned, now on again.